everybody, how's it going? Here's the first video in a series on something that I kind of low-key love, and that's Web Application Factory and .NET Core. Yeah, I did just say that I low-key love a utility class, and this is why I'm the coolest and I'm so insanely popular. Anyway, I'm going to talk about what WAF is and how to use it to write integration tests for your ASP.NET Core apps. And of course, as soon as I start recording this video, someone starts running a leaf blower. Hooray! Hopefully you can't hear that. Anyway, let's dive in. Here's a quick overview of what I'm going to be covering. Like I said already, the big topic is going to be ASP.NET Core integration testing. In the software development world, there are a whole bunch of different types of tests. Two big types of tests are integration and unit. I'm going to talk about what integration tests actually are, and also how they're different from unit tests. Then we'll get to the star of the show, Web Application Factory. This is the class in .NET Core that we'll use for our integration tests. Along the way, I'll talk about how our WAF tests are different than another type of integration test, UI automation tests. And then, of course, since this is a coding and software development topic, I'll do a whole bunch of demos. The giant first question is, well, what the heck is an integration test? An integration test is one of a half-zillion types of automated test. And the goal of this kind of test, just like all the other types of test, is to verify the behavior of an application, and do it ideally without human involvement. So how's this different than a unit test? If the goal is to validate the application, what's the difference between an integration and a unit test? Both of these types of test are intended to be automated, so run by a computer, validated by a computer, with results reported by a computer, so right there, they're similar. But the philosophies of unit tests and integration tests are different. Like all different types of tests, they have a certain approach for how they interact with the application under test and how they check stuff and what their validation goal is, different testing targets, different validation strategies. Automated tests in general are trying to validate your app so that you can quickly figure out whether it's working or not working. And the reason that you automate these tests is so that you have minimal human involvement. Humans are a whole lot slower than computers. Humans don't do exactly the same thing every time. Humans get bored, and humans have other things to do. Which is to say that on the teams that I work with, I like to see much less emphasis on QA testers or manual testers. And when I say less emphasis, I don't mean fire your testers. I mean that you should put way less emphasis on your human testers for the purposes of just finding out if the app is working. The more that you can automate your test suite, the more time that your human testers will have in order to do more interesting and important things like exploratory testing. Think agile testing. My overall goal is to have a suite of automated tests that I can run as part of my build and deploy pipelines. I'm a DevOps guy, so what I'm looking to do is to make the application validation be a key part of the compilation and deployment of the app. If you're thinking that unit tests and integration tests sound darned similar, it's because, well, they're darned similar. Let's do a comparison. When you're working with unit tests, your goal is to test small pieces of your code as you develop it. This is the unit in unit test. It's the small chunks of functionality that you're trying to validate. You also want to try to test those units in isolation. A way of thinking about this might be to think about testing a seat on an airplane. You're not focused on whether or not the airplane can fly, you're focused on whether or not the seat can recline. So that brings up the question of, do you actually need to fly the plane in order to check the seat recline? The answer is no. Testing small units in isolation makes sure that stuff is actually working at a low level, and it also helps you to test and debug when specific things are failing. Another thing about testing in isolation is that you're trying to avoid having to deploy the whole app in order to validate something. Continuing with the airplane seat recline testing, you don't want to have to gas up the plane and take it up to 40,000 feet just to find out if that seat reclines. Unit testing really tries to have you focus on just what you're testing and only what you're testing. This also means that since you're trying to not deploy the app and only test small bits of the app, you're trying to structure your unit tests so that they don't require their dependencies. This would be like bolting that airline seat to the floor and testing that it reclines rather than installing it in a real working airplane. You use test harnesses and fake implementations of the dependencies. For example, a fake implementation of your database repository interface rather than one that actually spins up Entity Framework and calls SQL Server. This is out of scope for this video, but mocks, stubs, and fakes are all different kinds of testing patterns that you can use to avoid those dependencies at test time. So that's a lot of information about unit tests. What about integration tests? Integration tests pretty much just do the opposite. We're accepting that in order to run the integration test that we're going to have to deploy the app. Our testing goal is probably a little different. We're trying to test that the system works when it's all put together, rather than finding out that all the individual pieces work. It's a higher level test that is checking to see if whole features or sets of features work. And like I said a moment ago, we're trying to make sure that the app works when it's all put together, and we're accepting that we'll have to deploy our dependencies. As you can imagine, integration tests are often a lot harder to run because they have so much setup. An example of this, and well, you'll see what I mean by harder to run and harder to set up. In order to run your integration tests, you might need to deploy everything. Spin up SQL Server, deploy the database schema, add some test data, configure your dependency injection framework, deploy your app to a web server, etc., etc., etc. The thing to remember is that unit tests validate at the API level, and integration tests validate at the feature level and/or application level. And as such, integration tests are a lot harder to run because they require so much setup. On the other hand, they're valuable because they can answer big questions about whether the app is working or not. And this is where Web Application Factory comes in to help us out with our integration test nightmares. WAF is a class that's part of .NET Core. It's a utility class, and it's part of the Microsoft ASP NetCore MVC testing namespace, and you add it to your projects as a NuGet package dependency. Don't let the word MVC distract you. This is for testing more than just ASP Model View Controller applications. Apart from the slightly inaccurate name, the idea is that you'll use WF to streamline your integration testing of any ASP.NET Core HTTP or web applications. What's happening under the surface is that WAF creates an in-memory web server. This in-memory server makes it super easy to run your web integration tests. So easy, actually, that I think it starts to blur the lines on integration versus unit tests. Deploying to a web server can be a huge pain, and a lot of the time, that creates a configuration gap between your development, test, staging, and production servers. With WAF, you can do a whole lot of testing that looks like the production server without actually having to be the production server. The big things that I'd be thinking about testing are my middleware classes or middleware configuration, root configurations for my web or web API controllers, and, because it's all linked together, tests for my dependency injection service configurations, basically making sure that I've registered all the type dependencies that I need. Personally, I'm surprised by how many developers have never even heard of Web Application Factory. I think it's unbelievably useful. Here's why I think you should use it. End-to-end testing without the overhead and headache of having to set up and deploy to a web server. You write and issue real HTTP requests against your application and validate that it's working like you'd expect. And it happens all in memory. It's isolated from pretty much everything else. You can do a whole lot of testing without ever having to really fully deploy your app. Thinking about running this on your developer workstation, you can do a whole lot of testing to check if the app is working. Ditto for running these tests as part of an automated build. When I write these tests, I find tons of configuration issues. Classes that I haven't registered in the dependency injection service framework, database connection strings or Azure keys or any other kind of config values that the app needs, basically making sure that they're all there. And if you want to start getting really fancy, you have the ability to customize your app's configuration on the fly. Basically, you have the option to create a test version of your application. Maybe I want to use a mock instance for some kind of service dependency, or maybe I want to simulate some horrific failure situation and test how my application handles that. Sometimes, for testing, I want to change the security config, simulate a bunch of different users without having to actually create and maintain accounts in Active Directory or Entra AAD or something, or just plain completely change the config settings for the app. Any of these test time configurations are possible using Web Application Factory. So just to spell it all out, what can you actually test with Web Application Factory? Answer: pretty much anything from ASP.NET Core. That means MVC applications, web API services, apps using Razor Pages, or if you're using Blazor for your UI, you can use that. And then finally, there's one that I didn't know until I started to create this slide, background services for your applications. Here are the major things that I tend to test. Controller classes, honestly, this is probably 90% of what I test in with WAF. So that covers MVC controllers and Web API controllers. Along with that, I test my routing config and my argument configs, essentially making sure that I'm getting the right controllers for certain root values, and that they're happy with the data that I'm sending to them. Custom middleware classes, these are straightforward enough to test with unit tests, but considering that, at least in my apps, these custom middlewares are mostly for hooking into the security pipelines, I definitely want integration tests for these. And also making sure that I've got them configured in the right order. Because if you mess up the order that the middleware classes are installed in the execution pipeline, you could end up with some completely bizarre results. And then related to any security middleware, I often write tests for my security logic. This would cover both authentication, who is the user that's calling the app, and authorization, what can the user do? This lets me get into testing the behavior of the authorize attributes that I might use on a controller and verify role memberships and security policy handler configurations. And now that I look at this list, I realize that there's a whole lot that I try to test in my apps using WAF. And after all that talking, I suspect that there's a new giant question in your head. What's the difference between Web Application Factory integration tests and UI automation tests? When I say UI automation tests, I'm thinking of tests written with frameworks like Selenium, Playwright, Protractor, or any of what feels like a half-zillion other testing frameworks. So let's compare UI automation testing with tests written using Web Application Factory. Most of those user interface test automation frameworks that I mentioned a moment ago, what they're doing is driving a web browser. So rather than making HTTP network calls, the testing framework knows how to drive the browser so that the browser makes the network calls. And it does this by simulating a user clicking and typing in your application that's running in that real or virtual web browser. And depending on how you've written the test framework reads the page data that's in the browser in order to validate what the app has done and what the browser has decided to display. When you're writing WAF tests, there isn't any browser. Everything's happening in C# using an instance of HTTP client. It's that instance of HTTP client that's creating all the network traffic. What you end up doing is writing C# to create HTTP requests that get run against your application. Basically, all the calls to issue get, post, patch, delete, calls against your web apps or web service apps. The HTTP client issues that call to the server, and it returns an HTTP response class back. That response has all the data from the call to the server, and then you'll write code to validate the response. User interface automation tests and Web Application Factory tests are both integration tests, but they're solving different testing problems in different ways. UI automation tests focus on driving the application using a browser, basically simulating a user in your app, while Web Application Factory tests tend to work on validating the app a little closer to the network level, and then compare those both to unit tests, and it's yet another testing problem and solution. Rather than testing the deployed application, a unit test tries to validate only small chunks of code at the API level. Anyway, enough talking. Let's do some code demos. First up, a basic Hello World test with Web Application Factory. Stay tuned.